Good morning, Year 8s. Thank you for engaging with our online lessons again. Please send me that message on Show My Homework so that we can see that you've accessed the lesson. Today's lesson is going to be assessed via a couple of My Maths activities, Recurring Decimals 1 and Recurring Decimals 2. And as you can imagine, that is our learning objective for today. Please pop any questions that you have to red@theroyal.school. I am going to be in school each day this week teaching the Year 10s, so it might take me a few moments again to get back to you, but I'll endeavour to do that as quickly as possible. And then if you do want to submit any work or notes to Show My Homework, that'd be fantastic. Just make sure they're self-marked as well. So lesson objectives today. Developing students are going to be able to use equivalent fractions, decimals and percentages. Secure students are going to be able to convert a fraction to a recurring decimal. That's a very quick learning objective, so most people are going to achieve that. And then excelling students are going to be able to convert recurring decimals to fractions. This is quite a little strange process. So there's a couple of examples, and this is the bulk of the My Maths work is based on today. On to our starter then. So I've got two questions, several parts, comparing some fractions, decimals and percentages. So question 1, can you choose the correct symbols, a less than, equals or greater than symbol? And then question 2 is putting the fractions, decimals and percentages in ascending order, so from smallest to largest. So if you'd like to pause the video until you've had a chance to have a go at those, we can run through what we should need to be doing for those. On to the answers then. So first lot should be fairly straightforward. If we talk about decimals, probably just to be consistent on these. So in part A, 32% is 0.32, so that's smaller than the 0.35. 4% would be 0.04, so obviously that's smaller than 0.4. 1/5 is 0.2, so that's equal to 0.2. 3/5 is going to be a 0.6, so that's greater than 0.55. And then if you deal maybe decimals for both of part A, 75% to be 0.75, and so would 3/4. And then 90% in the last one would be 0.9, so that's greater than 0.09. If you're going to put your fractions, decimals and percentages in order, you can see we've gone to decimals for each of those below. So 70% is 0.7, 3/4 0.75, 0.6 is already as a decimal, and 2/3 0.666 and carries on, which we're going to look at a little bit later. And then you can put them in order. Of course, when you put numbers in order, always rewrite them back in their original form at the end. So our 0.666 we write back as 2/3 as our second place in question 2. And likewise with the last one, again, it depends on what level of difficulty you're doing on these. So you might have done your 7/15 on a calculator, 7 divided by 15, or you may have used some long division to get that decimal. Now, if you're doing some long division, you might find that some of these decimals don't actually end. So you would just need to have a think about, well, 0.4 is 1 decimal place, 0.35 for our percentage there is 2 decimal places. So perhaps you only need to do your division to 2 or 3 decimal places in order to make that comparison. Any problems with those, please let me know at red@theroyal.school, and I can link you to a fraction, decimal, percentage video if you're not very confident with converting between. We're going to have a look at recurring decimals then. So to start off with, convert 8/11 into a decimal using your calculator. Well, on a calculator, remember that a line in a fraction represents a division. So we could do 8 divided by 11 on your calculator, or you could even put 8/11 as the fraction there and press equals, and then you should have a button with S arrow D on your calculator, and then that converts things from a scientific mode, which would be the accurate fraction, into a decimal mode, so that you can switch your answer on your calculator display there. So the calculator should display your number as 0.72. It's really important to notice that we've got the dots above the 7 and a dot above the 2. And what this represents is that those digits repeat infinitely. So it's a recurring decimal. So this would be 0.72, 72, 72, 72, 72, and so on and so on. So the dots above the 7 and 2 show those repeating digits. There are some more examples of recurring decimals and the notation that we might use. So 4/9 is 0.4 with a dot above the 4, and that shows that the 4 repeats infinitely. Something like 5/6, which is 0.83 with a dot just above the 3, is a slightly different way of showing that notation. This means that only the 3 repeats, so the decimal starts with an 8 and then there's an infinite number of 3's after it. We can also have more than one number repeating. So we could have, for example, 2 sevenths here. We've got 0.285714, and there's a dot above the 2, and the final dot should just be above the 4 there. Now, the dots in this repeating decimal represent the start and end of the repeating pattern. So the 2 is the start of the repeating pattern, the 4 is the end of the repeating pattern. So this would have the 285714, all of that section repeating. So 0.285714, 285714, 285714. So the dots are the start and end of that pattern. Or we could have something like 9 over 22 here, which is 0.409, and the dots are above the 0 and 9. Again, if you've got 2 dots, they denote the start and end of the repeating pattern. So it's just the 0 and 9 that repeat here. So this would be 0.409, 09, 09, 09, 09. That's how we show our recurring decimals. So they can be done in a straightforward way with either a division on the calculator, or if you wish, you could do them in a non-calculator way, by showing that we've got the long division going on, and as soon as you start to see some repeating patterns, you'd be able to end your division calculation and then just put the dots there to denote that. Now we're going to move on to converting recurring decimals into fractions, and this is a very particular process that you'll need to follow in a very stringent way. So write 0.8 recurring as a fraction. We start off by letting an algebra expression equal that decimal. So we're going to let x equal 0.8 recurring. And it's worth writing down a few of those decimal numbers rather than put the dot in this case, and we'll see why that is in just a moment. It'll help us with our next steps. The next step is we need an algebra expression that's going to help us to eliminate our recurring decimal part. So if we were to, for example, times this number by 10, then we'd get the expression equaling 8.8 recurring. And what we can see here is that the recurring part of the number, the 0.88888, will match up with the decimal part of this number, the 888 here. So actually, if we start to subtract one of the numbers from the other, we'll get rid of the recurring decimal part, and this is exactly what we need to do with the process. A key thing to remember with this is if you're trying to find the new expression, then we'll only be timesing by tens, hundreds or thousands in order to match those decimal parts of it. And in this case, because there's only one digit recurring, we can get away with multiplying by 10. Multiplying by 100 or 1000 would also work, but it'll be unnecessarily complicated. Once you have two expressions for your numbers algebraically where the decimal parts match, we can actually subtract one from the other. So if we do 10x take away x on the left hand side, we'd end up with 9x. And then if we did 8.8 recurring minus 0.8 recurring, we're actually going to get rid of that recurring part there by doing that subtraction, and we'll just end up with 8. This is the key point of this process then, and it ends up that we have a very simple equation to solve. 9x equals 8. So we can divide both sides by 9 in order to solve this equation, and we'd end up with x equals 8 over 9. And then that's written a decimal number recurring one as a fraction, and you can check that on a calculator if you need to. This fraction can't be simplified, and so we are done with this question. So there's quite a particular process here that you're going to need to repeat. It'd be worth writing down one of the examples of this at least for you to be able to repeat in future. So if we look at another example of these, we might have a 0.363636 ... recurring as a fraction. So we could have written that as 0.36 with a dot above the 3 and a dot above the 6. But for our process of writing it as a fraction, it's nice to see a few of those decimal points in action so that we can see them being eliminated when we do our subtraction later. So again, we'd start off the process here with x standing for 0.363636 and so on. So this time we need another expression that's going to match our recurring decimal part of it. In this case though, if we times it by 10 in this case, we're going to be 3.6363, and if I write that above 3, excuse my mouse handwriting there, 3.6363, you can see there that the decimal part doesn't actually match. So timesing by 10 isn't going to cut it for this expression here. So instead of timesing by 10, so we've got our two repeating decimal parts of this, we're going to need to times instead by 100. That was 36.3636, We can see there that the recurring parts of this decimal exactly match each other, and that's going to be perfect for the rest of this process. The 3's match, the 6's match, the other 3 matches, and the 6 matches. That's going to be perfect. We then do our subtraction. So 100x take away x on the left hand side is going to give us 99x, and 36.3636 minus 0.3636 will just give us 36. That again gives us our very simple equation to solve. So divide both sides of our equation by 99, and it gives us x equals 36 over 99. Of course, you might have noticed already that in this case, this fraction is going to be able to be simplified. So we can divide through and get ourselves down to 4/11 as our simplest fraction now. This is writing this recurring decimal as a fraction. So as long as you've got the decimal parts lined up and the recurring parts match, you're going to be able to do these questions. For our final example here, we're going to look at a more complicated version of this. So we're going to write 0.2371371 as a fraction. So we could have put a dot above the 3 and the 1 because that's our repeating part, the 371 here, not the 2, which means that our number is going to be slightly more complicated to try and match up here. So again, we're going to start off by writing x equals 0.2371371 here. And then we're going to need an expression that tries to match our original decimals in place. So if we times it by 10, we'd end up with 2.371371. No, that doesn't match, so that's no good. If we were to times by 100, we'd end up with 23.371371. Again, that doesn't match. And if you times it by 1,000, we'd end up with 237.1371,371. Now that one's actually going to work for us. The first decimal place doesn't match up, but the rest of the process does, and that's going to be perfect for us because it'll get rid of the repeating part. So it doesn't matter about that first decimal place, just the repeating parts match up. So 1000x is 237.137,137,137. Once we've got that, we can then do our subtraction. Left hand side, 1000x take away x is 999x, and then if we take away our right hand sides, 237.137,137 minus 0.237 is going to give us 236.9. Now again, we've got a simple one step to solve this equation, so divide both sides by 999 in this case. Then we've got another problem. We've got a decimal here as part of our fraction. Obviously, we talk about either fractions or decimals or percentages, so we don't like to mix the two. A decimal as part of the fraction isn't really an accepted way of having it written. So we're going to need to find an equivalent fraction that gets rid of the decimal. The easiest way to do that is to times the top and bottom of this fraction by 10. And that's going to get rid of the decimal. Now in this case, your fraction can't be simplified any further, but in the case that it could, always just check that you can. Now your calculators as well should help you simplify these. If you pop one of these fractions, perhaps not with a decimal in some calculators, but if you pop 2369 over 9990 into your calculator and press equals, then it should simplify it for you if you need to double check on these questions. So we've had 3 examples of this process. It is quite a technical process to get your head around, so we're going to leave it at that for our learning objectives for today. So I've got a few of these for you to try before we move on to the main My Maths assessment for this lesson. So if you'd like to decide how confident you feel with the topic, and then choose your red, amber or green activity here. Remember, red activity is going to be the one that has the most support. Amber will have a few hints on what to do, and then green leaves you to your own devices on this. And if you're feeling really confident with this, then we've got an extension question here to convert the recurring decimal of 2.1363636 into a mixed number with the fraction in its simplest form. So if you'd like to pause the video until you're ready for the answers to these few questions. And answers should be as follows. And if you were doing the extension activity here, we should have times our original number by 100 in order to match those decimals, and you'll end up with 99x equals 211.5, And then when you simplify that back down into a mixed number, once you've solved your equation, you should have 2 and 3 over 22 as your final answer for that one. Okay, self-mark if you're sending your work in to me, and if not, and then put your corrections in if there's anything you need. So that is our learning objectives done for today. So please send me that message on Show My Homework if you haven't already, and then we can move on to the 2 My Maths activities. So recurring decimals 1 is based more on turning fractions into recurring decimals, and recurring decimals 2 is converting our recurring decimals back into the fractions, which is a more long-winded process. Again, please send me any help messages that you might need some support with to red@theroyal.school. As I said before, it might take me a few moments to get back to you as I'm teaching a few lessons today, and then submit your work via Show My Homework. And again, if you're submitting work, it's really useful to have it self-marked. That way I can give you some much more specific feedback on the work that you've been doing. Thank you very much. I'll speak to you later in the week.